Welcome to the third instructional video on using the Numeris Model Builder Data and Simulation Analysis web app. I'm Wayne Getz and will be your instructor for this third session. It will cover the topic of epidemic forecasting using model parameter values obtained as discussed in the second session. The listeners also referred to the preprint that's available through a link provided on the home page of this website after selecting the button Instructional Material, where this and other training videos and instructional information are available. We will now briefly review the first and second sessions. In the first session, we discussed how to enter and change values in the default settings. In the second session, we discussed how to fit model parameters to the data. Specifically, we began by clicking enter here and getting to the settings page. We can either have the default settings or we can load some settings that are of interest to us in this particular session. So let me go ahead and do that. I have now loaded in a settings file called settings_israel.dat. And I have chosen to use the Israel data comma separated value variable files. Over here, you'll see that some of the settings have numbers that are part of the default and others are numbers that have been fixed through the optimization process. In particular, we have estimated using the optimization procedure, the contact rate parameter, the succumb period parameter, the initial values for the symptomatic infectious class and the contact class. We have also fitted social distancing switching function, social relaxation switching function, and a contact rate reduction and a virulence switching function. More specifically, we can go to the optimization page and we can see here we have a fit range of 130. In the previous session, we discussed how to carry out the fit. Here we're just going to have a look at the particular fit that we have at this point in time for the first 130 days, and we're going to run it. And you'll see that we have a pretty good fit to what are three different phases of the Israeli outbreak. There's an initial outbreak phase, then there is a social distancing phase, and then the social distancing phase is followed by a social relaxation phase where the outbreak starts to grow again. What we did is we fitted social distancing and 4 basic parameters to the first 31 days. Those parameters are the ones that you see over here, 1, 2, 3, 4. We also fitted the social distancing curve. Then what we did is we kept those values constant and we allowed the social relaxation values to vary in an optimization procedure where we fitted up to day 137. You can see we've only gone to 130 here, but we did fit to 137. And then after we had that fit, we then used a switching curve over here to fit the mortality so that the mortality also changes over time. So to have a look in more detail at these switching curves, consider the following graph. In this graphic, you see that social distancing switches on within the first week. So if this is March the 1st and this is the end of July, it switches on at the end of the first week of March and it climbs very rapidly until sometime in early April it's approaching its maximum value of something a little greater than 0.3. The social relaxation rate switches on at a very low level at the beginning of April, but is of not much significance until it starts to climb in the middle of May, climbing fairly steeply so that through June and towards the end of July, it's approaching its maximum at somewhere around 0.09. The daily mortality rate starts out at the beginning of March at 0.04 and drops precipitously so that by the end of April, it's approaching a very low level. This is likely due to the fact that the medical establishment has become much better at coping with the most severe cases of COVID-19 that are being admitted to the hospitals. We're now back at the optimization page, and we've fitted our procedures for getting a good fit to both the incidence and the mortality curve. So what we're going to do now is go on to the forecasting page. Here we are at the forecasting page, and you can see that we have a number of days that we want to forecast. The forecast starts at day 130, so that's after our good fit. We want to see what happens. We have the various values, optimization values. We see over here that if you're using the optimization values that we inherited from the optimization page, they're in green, and they're the same as the values over here. If we change any of these values, then the optimization value changes to red to tell us that we've changed a value. So for example, if I go back to 0.1 over here, and I do a forecast that goes out to day 274, so I'll run once. This is a deterministic forecast, and you can see that if conditions persist as they did throughout most of July, then there's going to be a very severe outbreak, and eventually that will run out of steam because most of the individuals have now contracted COVID-19 and the population is approaching herd immunity levels. As it approaches herd immunity levels, the outbreak starts to slow down, and finally the outbreak runs out of steam because there are no more, or there are very few individuals to infect. Most individuals now have gone into the immune class. If we now reduce this final social relaxation level by 90%, so we make it 0.01 instead of 0.1, then we can project what would happen. So let's see now, we'll do a single run. And we see that the population is brought down to levels that we saw at the end of early March, which is not very satisfactory. In order to do better than that, we would have to reduce this level by half, let's say, so that we've now taken the social relaxation rate and reduced it by 95%. And if we now run it, we'll see that by the end of the year, the level will be down to levels that were seen in early April and the middle of April. If we only reduce the social relaxation as it was at the end of July by 80%, so we make that 0.02, and now we run again, you'll see that we haven't done very much to reduce the current outbreak. We've just managed to flatten the curve. Now, if you look at this, you can see that these are deterministic runs. So we might want to do a stochastic run. A stochastic run means that we're including demographic stochastic processes. Demographic stochastic processes recognize that events happen with a certain probability rather than a determined proportion. And so some variation is now included in those runs. In order to have a look at this variation and plot the mean and plus or minus 2 standard deviations, we have to do a number of runs. So instead of running once, we're going to run 100 times. And when we run 100 times, we'll start to build up a cone of solutions that are likely to fall within the mean plus or minus 2 standard deviations on either side. So now in this graphic over here, you can see that this is the particular case we've been running. And if we run it 100 times, then this would be the mean plus or minus 2 standard deviations. This is where the social relaxation is reduced by 80%. This is the case where it's reduced by 95. This is the case where it's reduced by 90. And this is the case where it's reduced by 85%. So this really tells us that in order for the COVID-19 from August onwards to be controlled to the point where it can be extinguished by the end of the year, that we have to have social relaxation being reduced by more than 95%. Now we're back at the website. You can see that we're in our 6th run and we're beginning to build up the statistics. Now, these statistics are purely arising from demographic stochasticity. However, instead of a maximum likelihood estimate of parameters in, say, the initial 31 days, if we had done a Bayesian Markov chain Monte Carlo method, then we wouldn't have got a single value for the parameters that we were fitting, but we would have got the likely distribution of parameters. If we had drawn values from this likely distribution, then instead of getting narrow bands, we would get bands that were considerably wider. In order to undertake this analysis, we need a set of MCMC values. This website does not generate MCMC values. We hope in future to have a 4th page where one can do MCMC runs. At this point in time, our MCMC runs were done external to the website. To see more on this particular example, one can go to the home page and take a look at instructional material there, and in particular, look for the following public. This particular manuscript describes some of the optimizations that were undertaken in this particular session. This manuscript entitled Characterization of Israeli COVID-19 Outbreak Drivers and Forecasting Using a Versatile Web App discusses more fully the material covered in the sessions presented here, and the reader is referred to this for more detailed information. We hope that this website proves useful to you in your own endeavors in trying to better understand the structure of the outbreak in your own community. Thank you for watching and good luck with using the website.